Good morning students. Today I will teach class 9th chapter 8, that is motion. In day-to-day life we had seen a different type of objects that are in motion or in rest. So how we decide an object is in a rest position or in motion? So an object is said to be rest if its position does not change with respect to its surrounding or a reference point. So, an object is said to be at rest if its position doesn't change with respect to surrounding or with respect to time. So, when the object is said to be in motion, so motion or object is said to be in motion when its position changes continuously with respect to surrounding, with respect to time, or we can say that with respect to a reference point. For example, a car is moving on the road. So, we can say that a car is a moving object or a car is in motion. Also, we can say that if a pillar is standing between the road, that pillar is not moving with respect to surrounding. So, we can say that pillar is at the position of rest. Motion is of three types. Number one, that is circular motion, linear motion, oscillatory motion. An object is said to be in circular motion if it moves in a circular path. Then we can say that the object is in circular motion. Number two is linear motion. When an object is moving along a straight line path, then we can say that it is in linear motion. Next, oscillatory motion. When an object is moving to and fro, then the object is in oscillatory motion. So I have discussed you further how we describe the motion of an object. To describe a motion of an object, we need a reference point. What is that reference point? If I am standing here, I will calculate my distance or my position from this point to this point. So that point is called the reference point. So I cover my distance from this to this point. So that is why I am in motion. If I am standing here but not moving from this place, then I am in rest position. So the reference point is origin to specify the position of an object. So that's why it is a reference point. So next topic is scalar quantity and vector quantity. So the scalar quantity is the physical quantity which have magnitude but no direction. So that quantity is called scalar quantity. For example, distance, speed are said to be scalar quantity. Next is vector quantity, the quantity which have both magnitude. Magnitude here means a value, which means I move 5 kilometer towards east, which means it is the value of my distance covered. So that's why the vector quantity have both magnitude as well as direction. Because I said earlier, I travel 5 kilometer towards east. So it is a vector quantity, which is displacement and velocity. So example of vector quantity is displacement. Number two is velocity. So next is distance and displacement. So distance is the actual path or total length traveled by a object. What does it mean? If I am moving for 4 kilometers to here, then I am going 3 kilometers further, then I am going back 3 kilometers. So the total distance covered by me is 4 plus 3 plus 3. So it is the total distance covered by an object. So here when an object is moving from point O to A to B, then going back from B to A, then the distance is OA plus AB plus BA. So it is the distance. But on the other side, displacement is the shortest length between initial and final point, which means object starts from here, it coming back to here. This is the distance. This is called displacement of that object. So displacement is the shortest length between initial and final point. So here a point of difference is between distance and displacement. So distance is the total length, displacement is the shortest length. Distance is always positive, but displacement can be positive, negative or zero. Distance is scalar quantity because there is no need of direction. Displacement is vector quantity. Distance can be equal to displacement, but displacement can be equal to distance or it may be less than distance. So here is the all about the distance and displacement. So here I have done a numerical. I will done a numerical for you. So I had not write any statement. I will verbally tell you about the numerical number 1. If a body traveling along a semicircular path and moving from B to A, the semicircle has a radius 10 centimeter. What is the distance and displacement? So, as I told you earlier, the distance is the total path. As the object moves from this to this, which means B to A. So, how we calculate the distance B to A? So, here it is the perimeter of the semicircle, that is circumference of the semicircle, which is pi r. So, it is 3.14 into 10. So, that is 31.4 centimeter. On the other side, displacement is, it is a distance between initial and final point. This is the shortest distance. So it is 2 multiply r is radius, 2 multiply 10, it is 20 centimeter. So here is the numerical. So next is numerical number 2. As the body moves from 4 km towards north and 3 kilometers towards east, what is the distance and displacement? So displacement is the shortest path. This is the shortest path. So how we calculate the displacement? So displacement is, here we apply the Pythagoras theorem, that is x square is equals to p square plus b square. So AB is equals to under root OA square plus OB square. So OA square is 4 square plus 3 square. So it comes out to be 25 under root. So it is 5 kilometer. So distance comes out to be OA plus OB, that is 4 plus 3, it is 7 kilometer. So it is distance. So total distance what a body travel, it is distance. So the shortest length between initial and final point is the displacement. So the next topic is uniform and non-uniform motion. So firstly, uniform motion. A body is said to be in uniform motion if it covers the equal distance in equal interval of time. As you see graphically here, the distance and time are equal. So if a body covers equal distance and equal interval of time, then a body is said to be in non-uniform motion. If a body does not cover equal distance in equal interval of time, then it is non-uniform motion. So non-uniform motion is it of two types, that is accelerated non-uniform motion and next is non-accelerated non-uniform motion. So accelerated non-uniform motion is a body is said to be accelerated non-uniform motion if a body moves faster or it covers more distance as compared to time. On the other hand, deaccelerated or non-accelerated, if a body moves slower, so then we can say that it is deaccelerated non-uniform motion. So I will attach the PDF files of some numericals related to distance and displacement. Along with this video, you can try these numericals at home and try to answer the questions in the PDF. Thank you.